Thank you all my dear students. Thank you all my friends. Please watch all the videos and like, share and subscribe. I think this class is highly helpful. This was the entire video. I think this is very much beneficial to all students. So that is the conservative of mechanical energy. That is conservative of mechanical energy in a simple pendulum. So this is a simple pendulum. This is a simple pendulum. That is point B. This is point P. This is point B1. So let a simple pendulum consisting of heavy bob, that is B, from rigid support. This is rigid support, and this is bob B. So by a string of length L. So this is the string of length L. This is the string of length L. Let P be the instantaneous position of the pendulum. P is the instantaneous position of the pendulum, and X, this is the height X from the ground level B. V is the velocity at P. So B is the velocity at P. So potential energy, that is mgx, and kinetic energy, that half mv square. Total energy mgx plus half mv square. So let the pendulum comes to the position B1 to B. So initial velocity 0, final velocity, that is V, displacement, that is h minus x. So with the help of the formula v square equal to u square plus 2s, we can write that is v square equal to 2g h minus x. So we can come that is v square equal to 2g h minus x from equation first, that is we can write that is mg. So from the equation, that is E equal to mgx plus half mv square. So putting the value, that is v square, we get this. So we can write that is mgx plus mgh minus mgx. So we can write E equal to mgx. Since total energy at point P is independent of its height x from the ground, and it will remain constant at all points during the displacement. This is the law of conservation of energy. So today's class has been enough. I think this is highly helpful. Please share all your friends to my link. Please share the link of the channel to all your friends. Thank you.